This is tutorial number 4 for the chapter Refraction, and you can see I have a diagram ready here, which I'm sure you'll all be familiar with by now. It's just a diagram of a triangular face of any prism. We've taken here a triangular prism, and we've just shown an incident ray such that the refracted ray inside the prism is going parallel to the base, and again the emergent ray goes this way. So there are a few formulae you can derive from this whole diagram, and I think that's a slightly confusing topic, it's slightly lengthy, so that's what I'm going to do right now for you. I'm going to derive the two formulae that you can derive from this whole diagram here. So firstly, we're going to look at just one certain section of this diagram, and that is this part. Not just this part, sorry, this whole part here. If we just, I'm going to make an enlarged version of it here. Okay. So your angle of emergence will come somewhere here. Your R2 will come here. On this side again, same thing. I think I messed up the angles a little bit. It doesn't look very similar, but it's the same thing really. So I over here, the ray is going like this in this direction from left to right, and this of course is your angle of deviation. Now just look at your angle of deviation. It's kind of obvious. Look at the properties that you've learned for triangles. I think you all know that this angle on the outside, the exterior angle, is equal to the sum of the two opposite angles, which are these two over here. We can name them x and y if you like here. Now, so we know that delta is equal to x plus y using your triangle property. Now, we also know, I think you guys would have done this before in middle school as well, vertically opposite angles. When you have two lines intersecting like this angle is equal to this angle here, the one on the right is equal to the one on the left. So these are called vertically opposite angles. So you could apply the same thing. Angle of incidence is equal to this whole angle here. So therefore I is equal to x plus r1. So x is equal to I minus r1. We've equated this to x, and if you do the same thing for angle of emergence in this whole angle here, you're going to get y is equal to e minus r2. Same thing. If we just put these two values, x and y, into this equation here, what we get is that delta is equal to I minus R1 plus E minus R2. So we can write this as I plus E minus R1 plus R2. We're taking the minus common here. This is what you get. Now, this is not the expanded version. This is the expanded version rather. There's a more compact version where we're going to substitute R1 and R2 over here. But for that, we need to find out the value of R1 plus R2. Now, look at R1 and R2 in the diagram that we drew originally over here. Now, you have your triangle like this. You have parallel line running across. It's parallel to the third side over here. And I think you would have done on the similarity as well, that these two sides here, this one and this one, they get divided in the same ratio. And over here, we're just taking it to be equal. Say if this is x, this is also x, and therefore this angle here is equal to this angle here, again using simple triangle properties. So what we can say is that if this is your angle of the prism on top, you have these two angles, the orange angles that I've just marked in the original diagram. Now we have a normal here on both sides, and you have R2 and R1. Okay, now you also know, we know that these two angles, I'll take a different color and mark them, these two angles here are equal. And so we can, if you apply the sum of angles in a triangle formula, you'll get that 2x is equal to 180 minus a. So x is equal to 90 minus half a, or a by 2. This is what you get. Now we're talking about these two angles here being x. If we look at, we've drawn normals here, right? So that means that these two angles that they make with the refracting surface is also 90, which means that x plus r1, is equal to 90. That's simple math, I was just applying geometry, is equal to x plus r2. And now we also know that x, we found the value is equal to 90 minus a by 2. So just replace it and we get that 90 minus a by 2 plus r1 is equal to 90. So the two 90s get cut and you get that r1 is equal to a by 2. You do the same thing for r2 and you will get the same thing, that's equal to a by 2. And from this I'm going to continue this all the way up here. If you add r1 and r2, what you're doing is 2 into r1 basically, which is equal to a. You're doing a by 2 plus a by 2 and you get a. So r1 plus r2 is equal to a. Now look back at this formula we had over here. r1 plus r2 is equal to a. So if we replace the value of r1 plus r2, what we get is that delta is equal to I plus E minus A. This is how you derive it, and I hope you don't have any doubts over here. If you do, you can contact us, we'll tell you individually, but in your book there's a good derivation given. It's simple, but it's just a bit long. I've done the same thing really, but I've drawn separate diagrams, so I think it's a bit easier to understand for you. If it's not, then call us, we'll help you with that. Now also, this angle of deviation, it varies with the angle of incidence, and with the angle of incidence the angle of emergence also varies. And what you have is, if you draw a graph for angle of deviation with change in angle of incidence, I'm drawing it here. This is angle of incidence, this is deviation. You'll see a graph something like this. There'll be a lowest point here. Before that it's going to decrease, after that it's going to increase. This point is called delta min, or the angle of minimum deviation. That's called the angle of minimum deviation. And the angle of deviation now also, it has many factors that depends on, like the angle of the prism. We can see this formula and tell as well. Angle of prism, angle of incidence as well, material of the prism, because that'll affect the refractive index. Also wavelength or color that of the light that you use, that's also going to affect the refractive index. So those you just need to learn up. I can't teach you much there, and I'm out of time again. So definitely in the next tutorial we'll finish this chapter off. So I'll see you then.